Find ST. Now, ST is this guy. We'll also call it little r. Now, usually we do the law of sines, but the law of sines says that if you have like two angles and a side and you compare things up, then you use the law of sines. However, I don't have that. If you're given two sides and you're missing two angles, it'll be an absolute nightmare to use the law of sines. So we are going to use what's called the law of cosines. The law of cosines is best used, again, if you have two sides and only one angle, or if you have all three sides and you need to find some missing information about your angles. In this case, I have two sides, one angle, law of cosines. What is it? C squared equals A squared plus B squared minus 2AB cos big C. So if you're thinking Pythagorean thoughts, you're thinking right. A, B, and C are all sides, and big C is the angle opposite. So this would be like my little c, you would be like my big C, and you can be A or B. It doesn't really matter which is which. My job is to find R, which I'm calling C. So R squared is going to equal, if I call you A and if I call you B, that'll be 12 squared plus 16 squared minus 2 times 12 times 16 times cos 54. The nice thing about all of this is it's all one big terrible calculator problem. And when I throw that into a calculator, I get 174.2905. Am I done? No. In order to get R all by itself, I have to square root everything. And the square root of that terrible number is another terrible number, 13.202. Any units? Nope. But there you have it. Law of cosines is useful when I'm finding a missing side when I only have one angle but two other sides. Okay? Dunzo.